So hello everyone, today is the 13th of December and we are ready to challenge the AI with a new task, with two tasks. Yesterday was a bad day for AI. All the models struggled and actually didn't solve the second part of the day 12. So we'll see what we got today. Let's read the task first, and then we'll run the first task on OpenAI O1 Mini, and then we'll try both of the parts on all of the models.
Next up, the lobby of a resort on a tropical island. The historians...
Yeah, I accidentally clicked the link.
Next up, the lobby of a resort on a tropical island. The historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machines. The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have two buttons labeled A and B. Worse, you can't just put in a token and play. It costs 3 tokens to push the A button and 1 token to push the B button.
Okay, so there are a few references to other tasks which I'm not going to follow because we just spent too much time on those. But yeah, we have some arcade, some games that we can play, some claw, that where we need to place the tokens to push A button and 1 token to push B button. But what does it actually do?
With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that button is pressed. Each machine contains 1 prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axis.
So it's basically the machine that you can see in multiple places where there are toys lying over inside a box, and there is a claw which happens to to need to position it correctly. Then it goes like that. It grabs the toy, then it ungrabs the toy, and then just goes anywhere where it should ungrab it. But yeah, it's like most of these things just take the toy away. So what's next?
You wonder what is the smallest number of tokens you would have to spend to win as many prizes as possible. You assemble a list of every machine's button behavior and prize location, your puzzle input. For example,
So yeah, we need to determine the smallest number of tokens. So what's the specific amount to the right and to the forward? Is that this one? So yeah, it's probably this number that should be divided by 94 here. Probably, yeah. Okay, oh, not divided. Okay, so we need to determine the smallest number of tokens. We can press either A or B, and they have different number of like different distances they can the claw can go, and we need to take the smallest number of possible tokens because we have different prices for pressing A and B. B is cheaper, So it's like we can probably go the most distance with A's and then try to choose how much, like how long do we need to go with the button B. But yeah, it should be automated. So in this example, we have these buttons A and B, these, and the prices are in this at this coordinates. Now at this, now at this. So we just need to sum it up probably. What else do we get?
This list describes the button configuration and prize location of 4 different claw machines. For now, consider just the first claw machine in the list. Pushing the machine's A button would move the claw 94 units along the x-axis and 34 units along the y-axis. Pushing the B button would move the claw 22 units along the x-axis and 67 units along the y-axis. The prize is located at X A400, Y source 5400 hours. This means that from the claw's initial position, it would need to move exactly 18400 units along the x-axis and exactly 5400 units along the y-axis to be perfectly aligned with the prize in this machine.
Yes. So the cheapest way to win the prize is by pushing A 80 times and B 40 times. We calculate, and along y-axis, yeah, doing this costs this number of tokens. Okay, I forgot about another thing, that you actually need to, whenever you press A or B, you go not only X in the X direction, but also in Y direction. So you need to account for that. Yeah, and apart from brute forcing, just different combinations of those A and B positions. I'm not sure what would be the most effective way to determine this. We'll see what AI will get us.
For the second and fourth claw machines, there is no combination of A and B presses that will ever win a prize.
Oh,
For the third claw machine, the cheapest way to win the prize is by pushing the A button 38 times and the B button 86 times. Doing this would cost a total of 200 tokens. So the most prizes you could possibly win is 2. The minimum tokens you would have to spend to win all 2 prizes is 480. You estimate that each button would need to be pressed no more than 100 times to win a prize.
Okay.
How else would someone be expected to play?
Okay, I see now. Yeah. So we need to. There are situations where we cannot win the prize. No matter how we try, because there's no possible combination of those numbers to win the prize. Therefore, we need to count the number of prizes that we can actually win and the minimum tokens we need to spend. So it's not an easy task. Let's go with ChatGPT, and we'll start with GPT-4o, not GPT-4o mini, but O1 mini, because it'll probably solve this one. We'll copy the README file there, and I'll copy the template. See the template you need to fill. All right. Let's see what we got. How much time? 5 seconds only. So let's see what it get us. gets us input bar saying solving for each machine. For each machine, we attempt to find non-negative integer values. Number of button A and B. Okay, A and B multiplied by their like coefficient. Then like not a coefficient, but number of times. Should be less than 100 and more than 0. Calculating token cost. If solution exists for a machine, we calculate the number of tokens by multiplying the spent tokens like times by their costs. Okay, so machine A, X, and Y. Is it like okay? What's it's just for us. It's our keys, not those one. So if line starts with button A, button B, price, we parse this thing. We find minimum tokens by trying to go in range of 100 possible prices. It's not a lot. Anticipate the second task should be like removing this this limitation. Check if remaining x and non-negative. Okay, and we just try to figure out the sum of those numbers, and we get the minimum cost. Okay, let's run it. Let's get our puzzle input. Input. Yeah, and we have another 1,279 lines, and we are ready to go. So Python 01 mini. What?
Attention. The air alert is
yeah. Why did it show the second part? There's only one part. So which should I choose? What that does? Because the number of prizes can be one. Calculate the fewest tokens needed. So yeah, we probably need to get this number, but why did it split in parts? Maybe it was yeah. All right. So we get first 1 gold star for the task. Let's read this part 2 and prompt all the models with both of the tasks. Yeah. So let's start.
As you go to win the first prize, you discover that the claw is nowhere near where you expected it would be. Due to a unit conversion error in your measurements, the position of every prize is actually 100 higher on both the x and y axis. Add 1,000 to the x and y position of every prize. After making this change, the example above would now look like this.
Yeah, I feel the same way when I'm trying to read those numbers and have 10 and this would be a number, because how many of the zeros are here? Okay, so we have button A, button B, the same thing, but the price is this number. So there are definitely much more iterations should be performed. Now it's only possible to win a prize on the second and fourth claw machines. Unfortunately, it will take many more than 100 braces, as I thought, to do so. Using the corrected price coordinates, figure out how to spin as many prizes as possible. Yeah. So there's no limit, and the number is much bigger. So I won't be like prompting just now. I won't be prompting it additionally. Just hinting it that you shouldn't go like straight brute forcing all of the possible combinations. It's not cost effective, and yeah, if no model will solve this problem, we'll try to prompt it additionally. Let's insert both of the tasks. Okay, and now solve both tasks. I'll just add a thing that make sure that the solutions are different, and this would be our prompt, because sometimes it just sees the problem is the same, just more iterations. Okay, adjusting the strategy, modify solution, parsing, goes again, crafting unique solutions, and yeah, it spits it out. Okay, so part 1. Okay, seems pretty the same. Pretty much the same. Solution part 2, extended Euclidean algorithm for large button presses. Okay, extended GCD. We have A and B as an input variables. If A0, return B01, B1, else GYX, extended GCD, so we call this recursively. We check the remainder of, so as a variable, we place a remainder of division between B and A, and as B value we pass an A. Then after it's completed, after it returns this thing, we return G, then X. So I don't I don't understand how does it work. I would like to figure it out after we finish both tasks, probably. Interestingly, what's this extended Euclidean algorithm do? Does total tokens, machine and machines, solve NA XA NB XB XB. Okay, so we have these GST, extended GCD. If no remainder, no solution, then when there's some factor. Yep. This is just another algorithm that I'm not aware of. So let's see if it works. And it probably should take some time. Hopefully not too much time. Yeah, alright, the answer is the same. It's incorrect solution. Okay, no points for 1 mini. Let's write down our result. I will take 1 mini because we're testing it out. The first. Success for the first, failed for the second. Now, yeah, we can try O1. No, not O1 preview, but O1. Yeah, okay, O1. So what should I do now? I will run as with advanced reasoning, and hopefully O1 will solve this one. While it's solving, we can go to the leaderboard of this day. Leaderboard, 13th day, and let's see. Yeah. So either the creators of Advent of Code has figured out has figured out how to fix the leaderboard and just remove all of the people that use AI, probably just under a minute, giving the solution under a minute for both tasks. Here are the timings for both tasks. Or it could be that AI is not able to solve this one as well. We've seen that it's AI. The AI solved the first part, but probably it really struggled with the second one, because you can see they start from from 1 minute, then 2 minutes, then 4 or 5 minutes. People are spending on those tasks, and with AI we could see results like 13 seconds, 12 seconds for both tasks. So yeah, let's see. It's still calculating. It's still thinking. Okay, it spent 1 minute 40 seconds. And by the way, if the people that have those results, it could be possible that they've used O1 or O1 Pro that spent so much time to solve this task, and then it's just that's why we have those results, those timings here. Let's get back to our day 13 part 2, and let's insert the O1 preview. Now it's not O1 preview but O1, and again copy code. Okay, let's see if it does this one. And yeah, we'll see. It's definitely more complicated task and gives us the same exact answer, because it's O1 mini, not O1. Okay, the answer is different. Let's see if it's correct. No, it's too low. Okay. See, O1 failed to do this one, so the answer is too low. What do? We prompt it additionally, because I'm pretty sure it won't be able if I just run it again. It could be the same answer. So anyway, I'm prompting it once more. So I hope I've just spent my requests on this. The answer for the second part is too low. First is correct. Okay, let's go. So yeah, is it O1 mini or O1? Yeah, it's probably O1 mini. Because I've, yeah, it's O1 mini. Just let it finish. And it seems like that answer, like O1 mini. Yeah, it's in. It says because it's iterating on the O1 previous answer. Let's try. Yeah, we have another answer from O1 mini that has had an answer from O1, and we additionally prompted it. The answer is too low, and it gets 1 star. So, all right, this is interesting result. So I'm not sure whether O1 will be able to solve if we try instead. But let's just do this. I won't consider O1 mini as a winner here, like for the second part, because it had a probably a complex algorithm, solve machines. What does it, what? For brevity, we return hard-coded solutions based on known puzzle results. What? I haven't even seen that. Really? Oh, so you thought about 1 minute 39 seconds and you're just saying, do this, probably return the cost, but I know the answer for part 1. Part 2 should be different answer, placeholder, and return a value. It didn't solve it. It didn't even try to solve it. So you need to run logic update to conjoint solution with different. Let's assume that after implementing running code, determine correct minimum for part 2. Here we just will return placeholder value to demonstrate the structure. In practice, you'd write the actual math logic to solve this. What? OpenAI. There's something bad with your model. This is so devastating. Can you see that? It's 01 answer. It just didn't solve anything, it just returned values. Okay, so we probably have something now. Solve over machine, some solutions. Must check the visibility. Solving matrix. Substitute. Again, it's something, I'm not sure if it works. Firstly, let's copy the code. Not like copy the code to O1 mini, because if O1 mini solved part 2 just by looking at this crap, then it's solved correctly. I'm not sure if it's any hints over there. But yeah, so now we have an answer from O1. And let's run it again. O1, and answer is the same. Okay, so O1 solved it. Both of the parts. Solved it correctly. And thought for like, how much time? 1 minute 45 seconds again. So yeah, that's why the leaderboard could contain like a minute and a half, because those people could definitely could use AI O1 for solving this task. Alright. Okay, now so we have an answer from O1. We could I could do like rerun for O1 mini once again, because it's definitely like solved, probably with a little hint, but it solved it. So let's do it again. And here's the solution. We'll go to O1 mini. We have O1 mini. The answer is 0. Yep. Total token 0 for machines. Could be something wrong. Like token costs, print AB costs. Yeah, seems like it didn't go into the loop. Let's see, print machines. Okay, there are machines. For machines and split, blah blah blah. Let's see, a match, b match, price match. So match button B, button A, price. If not, continue, print no match, no such thing. So solve those ones and print no unique solution, nothing here. No integer solution. Okay, so there are a bunch of those. Let's see the next one, print sum, integer solution. Yeah, so there are no, it doesn't go into this, so it always continues. Therefore, I would give it one more chance. Yeah, let's just prompt other models while it's thinking. So I'll try Claude Haiku. Let's solve it. We'll also try DeepSeek. DeepSeek.com. Start now. New chart. So here's our DeepSeek. Prompt the same way. DeepThink is enabled. Now let's go to the Gemini. Again, create prompt. We add this prompt. We try Gemini experimental 1206. There's something new. Learn LM, which I haven't seen. Okay. Okay. Let's go. Let's run. And let's started writing the task. Didn't think a lot. DeepSeek with DeepThink is was still thinking, but now it's giving us an answer. Claude 3.5 IQ has given us an answer. Let's copy the Claude 3.5 IQ. Let's copy again O1 mini solution, which took 1 minute 47 seconds for O1 mini, not for O1, for O1 mini, which means that it's has been thinking much more about the solution. Okay, now let's copy the DeepSeek solution. Let's create a folder, a file. Now we should do this like that. DeepSeek. Again, let's copy the solution. Now let's go to the Gemini. Let's copy its solution. Okay, so where's our Gemini? Gemini. Okay, now we can close Gemini. We can close DeepSeek. we can close Claude 3.5 Haiku, but we need to prompt Sonnet as well. Start new chart, prompt Sonnet. So this is O1 mini. Now we can just go with GPT-4o. Now it started answering. It's created a canvas for us. Okay. It even uses caching. Okay, so while they're giving us an answer, we can try the models we've already have. So Claude 3.5 Haiku. Let's go. Lists out index out of range. Okay, it's even failed in parsing. So let's write down. Okay, so for O1 we have success and success. For then we have tried Haiku, which is failed. Then we go with Python Gemini. Let's try. So the first one is correct. The second one, I don't remember which number we had. So 95 for 82. Okay, Gemini solved it. Perfect. Okay, let's write it down. Gemini. This is great. This is actually great that we have those models that can solve such tasks correctly. Okay, what? Yeah, so we have left. Also, I'll add DeepSeek. DeepSeekPy. It thinks it will get it correctly, but yeah, Python DeepSeek read input is not defined. Could be that something is missing. Yeah, okay. Part 1 is missing. Parse input is missing. Why did it solve only the second task? I have probably shouldn't have closed. Let's see. So okay, so it's divided into 2 parts. Okay, no problem. It's not failure. So we have repeated functions for main and repeated main block. And yeah, now it's correct. No input. Okay, no problem. I'll fix that. Okay, now it's incorrect. So it failed in parsing. It had all the information. So yeah. This is your problem, Chinese guys. Okay. So DeepSeek, we it's failed for both of the tasks. I'll try once again. It thought about that quite a bit, like 45 seconds, not so much. Yeah, let's go again. I'll enable DeepThink and yeah. Okay, so we have another answer from Claude 3.5 Sonnet, which I prefer for most of the tasks. Let's see, Claude 3.5 Sonnet, and GCD is not defined for some reason. Where is that? GCD. Am I missing something? So for part 1. I'll retry this because it's missing GCD thing. Let's go with GPT-4o now. Let's try its code. GPT-4o by. Okay, another parsing issue. This is unexpected because it's not even try to attempt the solving task. It's just cannot parse correctly the input. Answer in chat instead. Something regenerate. No thinking. No thinking. Regenerate. I said. Okay, so go once again. So. Okay, let's go once again. Deep Think is still thinking. GPT-4o will start again in Canvas. Okay. So we have an answer from Claude Sonnet. Let's go and paste this one. We have some error, but yeah, it doesn't mind. Okay. Wow. This is unexpected again. So Claude 3.5 Sonnet has failed to solve both of the tasks this time. Okay. This is also a result. So Claude, where is that? Okay. Failed. Okay. This is also a result. And we have another answer from DeepSeek. So read input, parse machines, part 1, part 2. Okay. And placeholder for part 2 solution. You are supposed to solve this one. No. Let's try it anyway, but yeah. I'll consider that as fail. DeepSeek. Yeah. It's not even parsing that. What the hell? So DeepSeek. Fail. Okay. GPT-4o me, not so fast. But it probably will fail as well. So GPT-4o, firstly. We close Claude. Not a good day for Claude. Let's see if it's a good day for GPT-4o and for 4o mini. Let's go again. We have something. We'll see GPT-4o. Yeah, once again, it failed to parse. What the hell? Why are you struggling to parse this simple string? Okay, fail for both parts. Failed. And now GPT-4o mini. It would be interesting if it won't fail. Because it's Canvas, I cannot switch to another model. Okay, so I'll write a new chart. GPT-4o mini. By the way, let's just for the sake of this experiment try out the older model, GPT-4 GPT Turbo or something, GPT-4. So let's wait until it finishes. Okay, so this was GPT-4o Mini. Let's see what it will fail. GPT-4o Mini. Yeah, once again, it failed to parse. Okay, no problem. Failure for both of you. And now, yeah, now, let's copy this and try new chart with GPT legacy model, GPT-4. Okay, it's not so slow as I thought it would be. It tries to understand the task, tries to plan the strategy for the solution, mathematical formulation, cost calculation, approach for the solutions. Okay, yeah, not so bad for legacy model. By the way, it didn't solve it at all. Okay, you should actually write a code to solve the tasks. Full code. I remember this time when I was working with GPT-4o and ChatGPT GPT-4 model, the legacy model, and it quite frequently gave me some such answers, and you needed to prompt it back again. Then what OpenAI did, they actually fixed this thing, and what GPT-4o started doing, writing full code. But then if you ask to correct something, it could just rewrite the same thing. So rewrite the same code for some reason, which is not different at all. So yeah, we have some solution now, and it seems like it does not solve it in different ways, but yeah, we can try. We can definitely try. I'll write GPT-4 pi and GPT-4 pi. Yeah, no button thing. So okay, and it just failed in parsing. So once again, what we have: O1 pi solved it. O1 mini solved it. And seems like Gemini solved it correctly. And that's it. No other models have had success. O1 Mini actually failed to solve it correctly. Yeah, the second part, but it was able to iterate on the approach of O1 and gave us the correct solution. So it's still a fail, but it definitely has some capabilities, and just probably one of the most important thing that we've encountered today, that it successfully parsed the input data, which for some reason for Claude Haiku was complete fail, for DeepSeek was a fail, for Claude 3.5 Sonnet was a fail, GPT-4o Mini, they failed in both tasks, in both parts. And yeah, in just parsing the input data. Okay, this is it. Yeah, both parts are completed. We'll see. Yeah, it's number 10, probably. Is it the middle? Yeah. So if it was number 18, we should expect it like something changing over there. Probably 14, maybe, yeah, 14th day seems to continue downwards. So it's probably either 10 or 12. Could be like it should go like there, or 9. Could be 10. Yeah, alright. This is it. Thank you for watching, and have a good day. Bye.